Up here, I kind of wrote us some steps to remind us how we do fractions. So before, you've done fractions a long, long time ago where you had to add. And when you add and subtract, it's different than multiplication and division. For multiplication and division, you do not need to find a common denominator. You simply multiply across. For division, you change it to multiplication and multiply across. When you're adding and subtracting fractions, what we do is we have to make sure the fractions first have a common denominator. And you're going to notice the first few examples, they do. And so then we can go right to step 2. What you're then going to do is add or subtract your numerators and put them over that common denominator. If possible, then we're going to simplify. Okay. All right, so let's start with example 1. Example 1, we check and we notice the denominators are the same. And so I can go ahead and add my numerators. So I add m minus 3n plus m plus 3n and put it over one common denominator. Then I'm going to simplify. And so what simplifies here would be my minus 3 and plus 3n are going to give us 0. And m plus m is 2m. So I have 2m over 6mn. So that's the adding part. Now I'm going to simplify in the same way that I did yesterday, the day on Monday. So do you notice they have a common factor of m? So I can go ahead and cancel that out. The n is still on the bottom. Also, how many times does 2 go into 6? 3 times. So now what happens here on the top? That's not 0. When you divide a number by itself, that gives us 1. So there's still a 1 on the top. And on the bottom, we have 3n. Okay, let's hop then to example 4. So example 4, again, do you notice those have a common denominator already? And so I am going to go straight to adding. I have 5 plus n minus 6 over 10n squared plus 16n plus 6. Okay, now don't get all stressed out. Maybe you wouldn't get stressed out about this and thinking, oh my gosh, that's so big, I have to factor that. Well, I mean, potentially, but let's just take a look and make sure that I have the top first. I have my like terms and I get n minus 1. Okay. I am going to choose actually not to go any further on the bottom because I already know that I can't cancel anything out. How do I know that? Because this is all plus here, so there's no way there's going to be a factor of n minus 1. Does that making sense to you? That's going to cancel out with that in the bottom. So I'm going to leave that alone. Okay, questions on that so far? Okay. Then let's look at a couple other different types of examples. So what if I had run across something like example 2? In example 2, I have 2 different denominators. The simplest way to do that is to just take this guy, because there's an x plus 2, and multiply by 4. But I don't know if you remember this with common denominators. You have to do by both the top and the bottom. So I'm going to multiply both the top, I guess like that, and the bottom by 4. Now I'm going to have a common denominator of the 4 times the x plus 2. What I'm going to have to multiply top and bottom by this is this has a 4, but it doesn't. What? No, it's not times 2. I don't think. Why are you saying by 2 times 2? I'm trying to find a common denominator. So because this already has an x plus 2 and this has a 4, I'm going to multiply this one by top and bottom by 4. This one already has a 4 but doesn't have an x plus 2, so I'm going to do top and bottom by x plus 2. So now do you see now on the bottom, take a look at the bottoms. They have, both of these have both a 4 times an x plus 2. Okay, so my common denominator is 4 over x plus 2. Now let's add the tops. What's 4 times 5? We have 20. And then over here, we have plus 3x squared plus 6x. Are there any like terms that I can put together on the top? Nope. All right, so I have just 3x squared plus 6x plus 20 on the top, and then 4 over x plus 2 on the bottom. If you wanted to, you could write that as 4x plus 8. Okay, did I not put any subtraction in here? That's weird. Subtraction would work the same way, except you'd subtract. Let's hop down to example 5. Example 5 is similar to example 2, isn't it? Mm-hmm. So let's look at this one. What do we need to multiply the first fraction? What do we need to multiply the bottom and top by? We need to have a 4 there on top and bottom. And then on this, we already have that 4, but we would need to do an x minus 1 on top and bottom. Okay, so now that I have my 4 and my x minus 1, that's my common denominator. I put that on the bottom. On this fraction, I have a 24. And this fraction, I have my 5 plus 5x squared minus 5x. So again, looking at this, there's not really any simplifying that happens. We have 5x squared minus 5x plus 24 over 4 times x minus 1. Okay. How are we doing, guys? Why am I choosing to what? Rearrange them? So it doesn't matter if you write it this way. No, you could have left it that way, because the math teacher in me knows that typically we write the x squared first. So, but it's not necessary. This is simplified. Okay. Then these last two kind of fall into a combo deal. They, at first you look at them and they look like a little bit overwhelming. But they both involve addition, this one's subtraction, and division, because another fraction bar is division. So I'm going to tell you how to attack these. If you're a person who's interested in like the SAT, you see some of these on the SAT. That's why I put these on here. If you're a person who doesn't, it still falls under the category of what we're doing. Okay. I take a look at that and I notice this top has something I can simplify. Do you see how the denominators are already the same? So let's just simplify the top. What's 4 plus 16? It's 20 over 9. Okay, so that's the top, and then over 8. So how I like to think of this next, when I have two fraction bars, is a fraction bar is the same as a division bar. So I am going to think of this fraction bar as division, and I'm going to use what we did yesterday. So I'm going to keep 20 over 9 the same. I'm going to change this division to a multiplication. And what's the reciprocal of 8? Or flip the 8, what would that be? 1 over 8. So that is how you would change, I call that a stacked fraction to multiplication of fractions. Then the only thing that I can do is I notice that I could go 20 over 72 and then simplify, but I'm going to simplify before I do that. What can we take out of both 8 and 20? 4. So 4 goes into 8 2 times and a 25 times. Then I'm left with 5 on the bottom over 9 times 2, or 18. All right, and then finally, sometimes we see the same kind of thing with an X in it. Let's look at example 6. So we want to simplify the thing that can be added or subtracted first. So on that expression, do you see they both have an X on the denominator? So the common denominator is X. So I'm going to simplify this to 5 minus 4, which is 1 over the common denominator of X. On the top of my fraction, I still have the 5 over 4. Okay. I'm going to highlight that fraction bar. That's going to be like a division symbol, okay? So what, in other words, and then maybe I didn't explain this enough, you're awfully quiet. It could be just because you're tired. This really, what I'm saying is, this could be written as 5/4 divided by 1 over X. That's what I'm saying. And so when I divide fractions, what we talked about yesterday is we use keep, change, flip. So this is the same as 5/4 times X over 1. There's really no canceling out on this one. It would just simplify to 5X over 4. Okay. So as I mentioned before, instead of doing whiteboard, we are going to do some on a worksheet. So what I thought is, so you could have me help you. We would try some of these, one of each type. So we did one more together. So your assignment is going to be 1 through 15 odds, and then 23 and 25 if you want to go ahead and circle those. What I would like you to try is, would you try question number 3? So we're going to do ones that are on your homework, but we're going to try to do one of each type. So go ahead and try question number 3. It's already got the, oh, it's already got the common denominator. Doesn't it? No. Oh. Yeah. Try question 3. If you're feeling like, hey, I got this, man, just keep working. If you're like, hey, but try question 3, and we'll just do a check-in in about 30 seconds. All right, I'm going to give you the answer to 3. Those already have a common denominator, so you can just add your numerators. And the like terms are the 5 and 6. So this is 5a plus 6 over a squared plus 3a plus 2. How did we do? Can you give me a thumbs up, thumbs down situation? Okay. So can you simplify it?
Yeah.
Nope. There's no simplifying on this one. There's no way, like, if you look at the bottom, could you try to factor the bottom? A plus 1, a plus, you can, but it's not going to get you anywhere. Is it going to get you to cancel anything? So you don't have to factor it. The only reason you would have to factor in a scenario like we did last time was to get something to cancel. So you could, can you? Is it wrong? No, it's not wrong. But you could also just leave it like that. There's no way you're going to be able to simplify it further.
So you can cancel the 6 and the 2.
That's killing the cat. You just killed the cat. Well, you did it. Hypothetically, if you would do that, that's what would happen. That's what that's like. You can't do that because these are separated by addition. The only time you can't cross cancel is if they're separated by multiplication. Okay. All right. So through 5 is all common denominator stuff. Okay. Would you guys try question 11, please? Would you try question 11? That's my first. So I showed you my first 2 steps. Oh. So when you have 2 different denominators, you multiply by each by the other denominator. So over here I get a 3 and a 3. Over here I get a 12x minus 8 and 12x minus 8. So that part making sense. So then my common denominator, I literally just wrote it as 3 times 12x minus 8. I didn't bother distributing it. Could you distribute it? Is it wrong if you did? No, it's not wrong. But it is a common denominator. On the top over here, do you see how I got my minus 24? How did I get this? Because I have to multiply 12x minus 8 times 7. 12x times 7 is 84x minus 7 times 8 is 56. Is there anything else I can do on this one?
Yeah.
Yeah, there is. You could do 84x. What's minus 56 minus 24? Quite frankly, if you get to that far, you're doing good. The only other thing I do notice is that these terms all do have a 2 in common, so you could also pull a 2 out. But my point here is like, I'm really trying to emphasize the finding the common denominator part and adding like that. Okay, let's try one more. What about if there's totally 2 different things like this? Same deal. So what do you think you have to multiply this side by? I need to have, this side has to be by x plus 7 over x plus 7. What about over here? X minus 8 over x minus 8. See if you can try that one. I'll give you a couple more minutes and then I'll give you the answer. You don't have to worry about multiplying out the bottom. You can leave it as x minus 8 times x plus 7.